Development of digital twin operational platform using the Python Flask software. The thing is that we just need to add the complete digital twin operational platform in which we just called it short form DTOP. So the thing is that we just added the complete DTOP cloud form in software, and we just predict its complete data according to different years. Okay, these are the introduction, connectivity and accessibility of format for digital twin operational platform, and all the references and the data framework for the digital twin are added in this section. So this is basically the overview diagram in which we have just placed the standalone data acquisition from physical twin, and it processes the data in the server room. Okay, so basically, just a second. Yes, this one. Uh, in the physical twin, we just collect the data from our PC. This data is used as a server and provides the data to another section, and then this local it just communicate the data through wireless based. Okay, these are the servers used to process the data, and this is a wireless communication which sent the data from this station base station to another local area network station. Okay, and then in the next phase it also collect the data from data acquisition and this provide us data on the cloud system as well. Like we can access the data from our web-based laptop and the Android system, like in mobile phones as well. So this is the complete three proposed methods for the accessing of the physical twin via digital twin operational platform. So this complete section is developed in the Python based project. Okay, and next one is basically the interface, like how the interface work, interface layer, cloud computing layer. This is the interface layer and Internet of Things layer. In the complete section of the layers, we just calculated and provided the data links to different platforms. Okay, like in this section we just provide the data to the cloud services. This section, this layer, we just provide all the data set to the user layers, user devices, and Internet of Things we just provide the data to the actuator. Okay, like the physical twin data. So our main purpose is to provide the data in different platforms using this complete server. We have just developed the a server which collects the data from different platforms and provide us the data set to the users based on their requirements. Okay, so I have just added the digital twin operational platform. This is basically Cristallo sections. Like we have just stored the complete data set in form of layers. These are the layers used in it, like finite element analysis, uncertainty propagation. We just got all the elements in it. So in this diagram, we just provide us like how user input can do through CSS JavaScript. Like this is providing us the complete structure, like how the Python code is developed based on the user inputs, based on the third party simulation and Python API and the database accordingly. Okay. And the next part is basically database read and write system, in which Python based tool mentioned in it. And also we just added the complete section for the third party simulation software, which is Abacus, MATLAB software, Python tool, and Git repository for the standalone version as well. Okay. So upgrade the server based version, we just added the its server layout, like in which user machine and Flask machine can send the data bidirectionally, and also it provide us the data from radius server the PostgreSQL service server DAC machine radius. So all the dataset are interconnected and bidirectionally to communicate from one side to another side through IP addresses, through virtual hardware, through combination of both physical and virtual hardware. So this is the overview of like how I have developed the complete structure of the dataset. So basically, just a second. Yes, these are the conclusions used for this code and the references as well. And let me just provide you this one. Like this is the code we have used. This is the Python code we have used for the digital complete setup. And yes, all the code added in it and this section. And just a second, let me just, yes, reason it model also all the layers, all the models, all the contribution layers added in this section. Okay, we can run through this complete model as well. So this model is providing us the complete layer, and this is the MATLAB Simulink model used in our overview structure for the, just a second, like for example I have just added the MATLAB overview for the data acquisition and the data calculation. Like these are the compressed air, energy storage, control system, accordingly different data set. Like for example, we have just, yes, this one final project is, it is just a complete overview like how our server works accordingly. Okay. So next part is that the C++ code. The C++ code also provide us the it's the development of user-based encryption to secure our complete data set. Okay, in which user can add its name, password, and like author name, book name, password, ID, and everything. Okay, and yes, this code provide us the security purposes safety to secure the user's data. So I think this is okay now. Yes, this complete project is developed for you. Okay, thank you.